Hello everyone. So in the last video, we saw how to solve a non-homogeneous second order differential equation by using the method of undetermined coefficients. So if our general differential equation of second order looked like this: y double prime plus p of t y prime plus q of t y equal to g of t. So this was our non-homogeneous second order differential equation. So we saw an example last time that the function which is g of t, that is the non-homogeneous part, is not a part of the solution of the this homogeneous part, this equal to 0. Functions in g of t was not a part of the solution in the homogeneous part. Then we saw know how to solve the second order differential equation. But suppose the function in g of t, so let us take the last example only. In the last example, if you can recall, it was sine 2t. G of t was sine 2t. So suppose we have a differential equation where the homogeneous part has the general solution as y ct equal to some c1 cos 2t plus c2 sine 2t. Then you can see that this thing, the sine 2t, is a part of the solution. So then the trial solution a sine 2t plus b cos 2t will not work. So in that case, the trial solution yp t which we take, that has to be, so a sine 2t plus b sine 2t. This will not work. Instead, we have to take multiple t times of this thing as our trial solution. So this is one case. So it may also happen that the number of times the solution occurs is more than once. So here sine 2t occur only once. Okay, but suppose you have a differential equation where uh, g of t is suppose e power t. G of t is e power t, and also the solution of the homogeneous part contains e power t. That is, the characteristic equation of the homogeneous part contains 1 as a multiple root, means 2 times. So the solution, suppose it was c e power t plus c2 t e power t. So it was the solution of the homogeneous equation if the multiplicity of 1 is 2. Now in that case, since e power t occurred twice, so the trial solution in the case of the non-homogeneous part, it has to be t square a e power t. So how many times this solution occurs, this thing occurs in the homogeneous part? You have to take t to the power that multiplicity, suppose m, t power m times the usual trial solution. So this is one technique. Okay. So now it may also happen that the solution in GT, the table we saw, what are the possibilities of GT we can have is e power alpha t, this type of things we can have, or some polynomial in t, this thing we can have, or we can have sine alpha t cos beta t. These things we can have in GT, but also we can have combinations of these things. For example, some complicated differential equation may have gt as, suppose, t square plus t times e power 2t. So that is, so this part is the polynomial and this part is the exponential part. So now we assume that neither this polynomial nor this e power 2t happens to be a part of the solution of the complementary function. Then the trial solution, so how we'll choose the trial solution? So trial solution ypt equal be, for the polynomial part you do separately, that is at square plus bt plus c times e power 2t you do separately, that is here logically you have to write d e power 2t, right? But since we are already taking the coefficients into consideration a, b, and c, so we can merge this d into this thing. So we can just take at square plus bt plus c into e power 2t. This only we can take as a trial solution, so it will not be a problem. Now, similarly, if suppose e power 2t was already a part of the complementary solution with suppose multiplicity once, then you have to take a t square plus bt plus c into t e power. So if e power 2t occurs once in the homogeneous solution yc. So this is that thing. So these are more or less the topic. So let us go through a concrete example to see what happens. So let us consider the following differential equation: y double prime plus 6y prime plus 10y equal to t e power minus 3t cos t. Okay. So this thing is our gt. Suppose it is star. So you can see that it is a mixture of all the things we have. Okay. So let us find the characteristic equation for the homogeneous part: r square plus 6r plus 10 equal to 0. So 10, so r equal to, so here it is, I think it will complex, it's minus 3 plus minus I. Hence y ct equal to c1 e power minus 3t cos t plus c2 e power minus 3t sin t. So this is the solution of the homogeneous part. Okay. So what you observe that this thing e power minus ct cos t is a part of the homogeneous solution, right? But t is so for this thing we have to take t times of the solution. So let us see how the trial solution looks like. So let us just write down. So g of t was t e power minus 3t cos t, right? Now we have to do for each part individually. So for this t part we will have at plus b, suppose, fine. Now for this part we have to take as a whole because this part occurred in the homogeneous solution. So let us see how does the trial solution looks like. So trial solution ypt. So this is t outside of the whole thing because this occurs in yct. So t times a t plus b e power minus 3t cos t plus ct plus d e power minus 3t sin t. So this will be our trial solution. So our main aim was to guess the trial solution. So this is the thing. So you can now complete solution of the differential equation. Okay. So this was the more or less thing. Okay. So one thing I wanted to point out here. So suppose we have this general differential equation where g of t is none of the standard functions. That is, it's neither e of some alpha t nor the polynomial sine cos or any mixture of these functions also. Then we can't use the undetermined coefficients to solve that because there is no trial solution according to our table. So in that case, we will use the variation of parameters method to solve the second order differential equation that we will learn in the next video.